So we've developed a microfluidic device for the high throughput analysis of nanoparticles suspended in fluids. So the device can electronically size and detect and measure the concentration of nanoparticles. We've demonstrated that the tool has really high resolution between different sizes of particles, which is a new feature in the field. And we've shown that we can detect both synthetic nanoparticles as well as biological nanoparticles like bacterial viruses. We've also demonstrated that it can detect these particles in biological fluids such as mouse blood. Nanoparticles are being used in a huge variety of applications these days, and people are developing more and more applications. So, for example, they're used as additives in composite materials, they're used in cosmetics, but they're also used in medicine as drug delivery vehicles, and all sorts of applications, and new ones being developed all the time. So one main application we see for our device is as a quality analysis or quality control tool for these industries. Also, on the other side, there are fundamental research applications in biology and medicine that could use this technology as well. So the heart of the device looks like this. So there are two components. The first is the microfluidic chip, which is this clear part. It's a piece of glass with a polymer that's molded on top of it. And also then that's attached to this electronic readout chip as well that has some very simple electronics. So the device is like this. It's small and in principle could be fit into a portable readout device.
So this technology advances the field of nanoparticle analysis by adding an instrument to the suite of instruments that's already there that can measure individual nanoparticles and distinguish different nanoparticles by their size at a level that far exceeds anything that's presently commercially available. So there are two things that we would like to add to what we can do with our current instrument, and there's one thing we would like to understand. The two things we would like to add are we'd like to be able to measure a much wider range of particle sizes at one time. Right now we can measure a fairly narrow range, but we think with a simple change we can improve that. And the other thing we want to do is to reduce the minimum size of nanoparticles that we can detect. The thing we want to understand is what is the limit to the resolution in the size that we can achieve with this instrument, because improving that would really help using it as a diagnostic tool.